So, if we assume that there were not enough 4x4s and SUVs driving around in the medieval warm period, what natural causes might there have been for the climate fluctuations over the past 1,000 years, which we now have really rather good grounds, I hope you'll agree, for suspecting may actually have occurred? Well, now we'll go on and have a look at one possible guilty party. And that's the sun, which is where, after all, the heat comes from. At the moment, the polar ice caps of Mars are melting. There has been warming noticed on the surface of Jupiter, on one of the moons of Neptune, even on far distant Pluto, all at the same time. And why is this? Because astronauts are taking their 4x4s up into space? No, it's because the sun, as we'll see, has been remarkably active. Now, Herschel, the astronomer, in 1801, noticed that when there were more sunspots and therefore more solar activity, grain prices went down because everybody was growing more grain. And this was in an 11-year cycle these sunspots tended to go. And even in that 11-year cycle, you could detect the changes in the grain prices, because even in the relatively small changes between the maximum and minimum of a solar cycle, that was enough to influence the way the grain grew, and Herschel spotted it. Now, let's go to this very interesting paper by Sami Solanki. He's one of the most expert solar physicists. He's very balanced. He doesn't take either side in this debate. What he says is the level of solar activity during the past 70 years is exceptional, and the previous period of equally high activity occurred more than 8,000 years ago. We find that during the past 11,400 years, the sun has spent only of the order of 10% of the time at a similarly high level of magnetic activity, and almost all of the earlier high activity periods were shorter than the present episode. So there is clear evidence that the sun is a lot more active now than it has been at any time since really the end of the last ice age. It's a quite extraordinary result. We go on then to look at the mismatch between CO2 and temperature over the period from 1880 to 1990. Now here you've got the CO2 graph, broadly similar to what I showed you before, going up in a sort of near exponential curve, and here you've got temperature jiggling up and down all over the place, and there really isn't a very good match between the two. So temperature doesn't track CO2 well, we've seen that, but it does track solar activity rather well, as several papers, which I'll now demonstrate, illustrate. Here's one from Solanki again and his colleague Fligg in 1999. The proxy for solar activity here is the length of the solar cycle. Quite a good track with temperature, as you may think. We go to the Central England temperature, tracking solar activity. That's from a paper by David Bellamy in 2007. Then we've got one showing that monsoon activity tracks solar activity. This is in the paleoclimate now, going a long way back. This is Neff et al. 2001. And then, of course, there's the Arctic, where again you see a rather nice correlation between the two. So the question then arises, we've seen all these different correlations from the scientific papers. I could have shown you dozens more, but time does not permit. How much influence can the sun actually have? Is it really as small as the IPCC would have us believe? Weren't there frost fairs on the Thames in the 60-year Maunder minimum when no sunspots were seen for ages? Well, the longest instrumental temperature record in the world is the Central England temperature series. Now, this series is very interesting. It shows that temperature rose 2.2 Celsius in 35 years between 1700 and 1735. The sun, not human industry, was the cause. Here it is over at the left-hand side here. A very steep increase. Now, we have to be careful when we cite evidence of this kind, because this is the oldest instrumental record we have, and therefore the instruments may not have been all that reliable. We're also dealing with temperatures in only one place, Central England. This might not have been a global effect. But even so, it's suggestive of the possibility that the sun, coming out of the Maunder minimum here, could have had a very considerable influence on temperature, an influence which would be wholly absent if you used the IPCC's very small estimate of the solar forcing. So is Solanki right to say that in the past 70 years there's been a period of exceptional solar activity? It's certainly exceptional in recent history. Here is the trend. This is done by another formidable solar physicist who has very close relations with NASA. This is Hathaway, and he shows here was your Maunder minimum, practically no sunspots at all. This is the sunspot number on the scale here. It's been smoothed a little, but it does suggest a pretty clear trend of ever increasing solar activity going back to the year 1700. So we're looking at nearly 300 years of it. So then we come to the conclusion, and this is not my conclusion, this is the conclusion of the International Astronomical Union Symposium in 2004. This is what they said. This is not me talking here. Solar changes cause most climate change. Solar cycles are 11, 80 and 200 years long. We've seen the 11-year cycle very clearly in the charts we've seen. The sun caused today's warming. Today's warming is normal, not unusual. Today's warming will end soon.